Okay, so yesterday we did day 6 and started day 7, which was addition. So what we have left for day 7 still is subtraction and scalar multiplication, which we're going to show graphically as well as check algebraically. So for subtraction, I just want you to think about it as an addition problem. So if we had negative 4 minus 5i minus 4 minus 3i. What I want you to think about is just like when you subtract numbers, you can add the opposite. And when you add the opposite, you can actually distribute that negative through and it becomes negative 4 plus 3i. So when you see a subtraction of two complex numbers, I really want you to just think about it as an addition problem and you're adding the opposite. So we still start with this first complex number, which we're going to go left 4, down 5, and we're going to plot our point and we're going to connect it with a dotted line because it's not our final answer. And then from there, we're going to continue to go, so we have negative 4 plus 3i, so we're going to go left 4 from there. So we're going to go 1, 2, 3, 4, but now we're going to go up 3, 1, 2, 3, and connect to that point, and that's actually going to be your final answer. Go back to the origin and connect to that final point. So this one in green is our answer, and you can see here you've gone left 8, down 2, and that's the final complex number. Now algebraically, you're just adding like terms. Negative 4 plus a negative 4 is negative 8. Negative 5i plus 3i is minus 2i. So anytime you see a subtraction, just think of it as adding the opposite. So distribute that negative through, and when you draw it, treat it like an addition problem like we did yesterday in class. All right, now the last thing, so that's what subtraction is, okay? So if you feel you need to re-watch it, just start the video over and watch the process again. Number 2, what we're going to look at next is what's called scalar multiplication. And all that's going to do is change the length of a complex number. So if we have a number in front of a plus bi, which is k, that's like our scalar, what we can do is distribute it through, and it can either lengthen or shorten the horizontal and vertical distance. So let's go ahead and look at the number 3 minus 4i, okay? So we're going to start by graphing it, which is right 3, down 4. And so this is the complex number 3 minus 4i. Now let's think about the modulus. That's something we learned yesterday. If I take the absolute value of 3 minus 4i, how far away is this point from the origin? Well, by now you might recognize, oh, that's going to be a 3, 4, 5 triangle. If you don't recognize it, you can do what we learned yesterday, a squared plus b squared, and that gives you the square root of 9 plus 16, which is the square root of 25, which is 5. So starting off with this number, 3 minus 4i, it's right 3, down 4, has a modulus of 5, meaning it's 5 units away from the center of the from the origin, 0, 0. Now, if we put a scalar in front, let's say the number 2, think about how do you think that's going to affect the number 3 minus 4i? Well, what happens when we distribute it? 2 times 3 minus 2 times 4. Notice each term doubled. So now we're going 6 to the right and down 8. So we're right about here. And if you go back here and extend it, notice that it's in the exact same direction, right? It's just an extension of the original one. Now think about, if you had to guess, what would the modulus of that be? Okay, that's what it looks like graphically. It's equal to 6 minus 8i, But what do you think the modulus is? How far away from the origin do you think it's going to be? So let's go ahead and do it. If we plug in 6 and 8, you get 36 plus 64, which is the square root of 100, which is 10. Notice that the distance that the point in red is away from the origin is double the distance that the point in black is from the origin. All right, what do you think is going to happen if I say, let's try 1/2 of 3 minus 4i? Okay, is the direction going to change? Are we still in the fourth quadrant? Do you think the modulus will change? So let's see what happens. If I distribute a half through, I get 1.5 minus 2i. So let's go. Write 1.5 down 2. Here it is. Okay, that's the number 1.5 minus 2i. So think about, what is that distance compared to the original 3 minus 4i? Is it half? Can we try it? Can we use our calculator maybe? So if we want to take the absolute value of 1.5 minus 2i, that's going to be 1.5 squared plus 2 squared. If we plug that into our calculator, we should get that that is equal to 2.5. So it makes sense what we just did in all of these. We started with 3 minus 4i, which was in black there, had a modulus of 5. When I put a scalar in front, I'll call this part B. When I put a scalar in front of that, of 2, it doubled that distance, right? Notice they're all right on top of each other. They're just different lengths. And that's what you can see based on that scalar. Now, a scalar can also be negative. So let's take a look at what does a scalar that is negative do to a complex number. So if we have number 3 here, let's say I have 2 plus 3i. Okay, so let's think about what quadrant are we in. It's not a straight line, but that's all right. So we're going right 2 up 3. Okay, if we want to figure out that distance the point is away from the origin, we could do the absolute value of 2 plus 3i, which is 2 squared plus 3 squared, which is 4 plus 9, which is square root of 13. So it's telling us this distance right here is a square root of 13. So somewhere between 3 and 4. So now, let me call this part A. Now if we look at the number part B, what if we throw a negative 3 in front? How is that going to affect it? Think about which quadrant is it going to be in. It's currently in the first, but if I multiply it by a negative 3, what's going to happen? Also multiplying it by a scalar of 3, what's going to happen to the modulus? So let's take a look at this. If I distribute my negative 3, I get negative 6 minus 9i. Notice what happened here. You're going left and down. Notice you're in the opposite quadrant of where it originally started. Does that make sense? Because we multiplied through by a negative. Yes, right? It's going in the opposite direction. So that is negative 6 minus 9i. Now think about the modulus of that. Do you think the modulus, the distance, is going to be 3 times radical 13? Let's check it out. That's going to give us the square root of 6 squared plus 9 squared, which is the square root of 36 plus 81. When we add those together and start factoring, we get 9 times 13, which gives us 3 radical 13. Notice it's triple the distance. The one in red is radical 13. The one in blue is 3 times that, but in the opposite direction. So that's it. Okay, so now you guys should get caught up with days 6 and 7, so you have the rest of the class period to do that. If you need to rewatch anything, just rewind it and rewatch it, and I will see you on Thursday.